And the next page is, I'll start doing the graph. What about horizontal asymptotes? Horizontal asymptotes you get by taking the limit as x goes to infinity. What's the limit as x goes to infinity here? 0 is correct. We do have a horizontal asymptote, y equals 0, the x-axis. And if we take a look at the limit as x goes to negative infinity, we will get what here? 0 again, absolutely. Okay? The x-axis, y equals 0, is a horizontal asymptote.
Why'd you do that twice?
Well, one we went to positive infinity and one we went to negative infinity. For our functions, those are going to be the same, okay? But there are functions where they're not the same, and you really should do both, okay?
We're going to 0 because the denominator is going to create a larger number.
Faster, yes.
Faster.
Yes. As long as the degree of the denominator is greater than the degree of the numerator, that limit will be 0. Okay? Okay, so we have vertical asymptotes, we have a horizontal asymptote at the x-axis. All right, let's go. Next page. Those are test questions, okay? I will ask for vertical asymptotes. I will ask for horizontal asymptotes, okay? Let's take a look at the graph. We're going to have to do first and second derivatives as well. These are going to get a little bit nasty, but let's take a look and see what we have for a graph so far. So far, we have vertical asymptote at -1 and a vertical asymptote at +1. We also have a horizontal asymptote at the x-axis. Now, it is possible that this graph crosses a horizontal asymptote, but what we do know, as x goes to infinity, the graph is going to approach this thing either this way from above or from below, but it's going to get closer and closer to the x-axis. Because we have a vertical asymptote here, we know the graph is either going to approach it this way, go to positive infinity, or this way and go to negative infinity. So basically, on this side, we have this possibility or this possibility. That's basically what we have. In between here, we have a few possibilities. We could have this, okay? We could have this. We could have this, or we could have this. We get those, the first and second derivatives are going to tell us. And on the other side of -1, we've got this possibility or this possibility. Those are all the possibilities we have. There can't be anything but those, okay? Because of the vertical asymptotes and the horizontal asymptotes. Which one of those is going to be correct? That will be determined by the first and second derivatives. So let's do it. First derivative. And like I said, these get a little nasty, but just hang in there, all right? We can do it. First derivative is equal to, and I'm doing x over x squared minus 1, yeah. Okay, quotient rule, denominator. Derivative of the numerator minus numerator times the derivative of the denominator all over denominator squared. Okay? That's equal to, we have an x squared minus a 2x squared. And we have a -1 here. We have an x squared minus 1 squared here. I'm going to take a -1 out of these two, and say x squared plus 1 over x squared minus 1 squared. Okay? Okay, how are we doing?
So you factored out a -1?
Yes, I did. I factored out a -1. Okay? Now, we want to know where this is positive, negative, and 0. Let's do it. First derivative, positive. Well, let's see. What can you tell me about the numerator? assuming you can see it, of course. What about x squared plus 1? What do you know about that? What is it?
Is it a problem?
It is a parabola. If you were to graph the numerator, x squared plus 1, it'd be a parabola concave up whose vertex is 0, 1. Would it ever get below the x-axis? No, it's always positive. The numerator is always positive. What about the denominator, x squared minus 1 squared? That's always positive except for plus or minus 1, which makes it 0. But it's at those points we have our asymptotes anyways. We don't really care. So here's the deal. Always positive here as long as x is not plus or minus 1. But the whole thing would be negative. That is correct. Very nice. Because this whole thing is going to be positive for every value of x except plus or minus 1. This is always going to be negative. In other words, where is this first derivative positive? Nowhere. Never. Where's the first derivative negative? Everywhere, as long as x is not plus or minus 1. Everywhere else it's negative. Where is this thing equal to 0?
You plug in 0?
No. What's that?
And its origin?
No.
It's not.
No. It's not, is correct, if that's what you're saying. It's never. Okay. Fractions are equal to 0 only when their numerator is equal to 0. This numerator is x squared plus 1. That is never 0. Therefore, this fraction is never 0. We have no horizontal tangent lines here. Okay? What does this tell us? This tells us that this is a graph that's falling all the time. Okay? It's falling all the time. All right? It's never rising, and it's always falling. It's got no horizontal tangents. Okay? Falling all the time. Of all the scenarios that I gave you, there's only one that gives me a graph that's falling all the time. And I'll tell you, right now I can tell you what this graph looks like. It must look like this, falling, and it must look like this, falling, and it must look like this, falling. That's the only possibility for this graph to be falling all the time. But we're going to verify this with the second derivative. Okay? You ready? Is everybody okay?
So what we're doing today is pretty much
What I'm
review,
Yeah, that's it.
and the odd and even stuff, right?
And that's more review too. And that odd and even's not specifically on the test. That's mainly for you. Oh, and I'm glad you mentioned that. Is this graph that I've drawn here illustrate an odd function? Does this graph have the symmetry with respect? Yes, it does. You take a point here, draw it through the origin, bring it out to here, the origin will bisect that point. Take a point here, yes. This is an odd function.
How do
right
you know
here.
it's not again? I mean, I looked at the notes, but I'm not getting how it's negative, how negative makes it a negative.
Well, if you take, here's the function, and you replace x with its opposite. Here, let me do a value. Let's take 3. If you take 3, you're going to get 3 squared minus 1, that's going to be 3/8. And if you take negative 3, you're going to get negative 3. And negative 3 squared is still, 3 squared is still 9 minus 1 is still 8. The denominator is not going to change as it goes from positive and negative. The only thing that will change is the numerator will go from positive to negative. How is this related to that? It's the opposite of it.
Negative.
Yeah.
Okay, so that just makes it odd.
Yes.
If it came out, it would have been even if it.
If it came out 3/8 and it was didn't matter, then it would be even. Yeah.
That means it's symmetrical over the origin.
Yes, that is correct.
Okay.
Yes.
If you can't intuitively derive like the assumptions of that it's falling on the left side of, when x is less than -1, can you take a point, say -2,
Sure.
and would you put that into the first derivative?
No.
The original?
The original.
So you're always putting it
Into the original.
function?
Yes. Yeah.
Okay.
Yeah. But let me just go over that, though. We said this graph is falling all the time, and I gave you two scenarios for approaching this vertical asymptote. Here's one scenario, and because we had a horizontal asymptote here, we knew, and here's the other scenario, and this is the one that's falling, and that's all it could be. But we are going to verify with a second derivative. So if you can't do it directly from the first derivative, the second derivative is going to help you. Let's do the second derivative. Now, second derivative is very nasty, okay? It's very nasty. I don't know what to tell you except it's extremely nasty. Here we go.
So you're saying that it's nasty?
Yeah, I'm saying it's very nasty. Okay, we got this negative here. Let's forget about the negative for a minute. At the very end of this problem, I'm going to put the negative back in, okay? It's a -1 times this. I'm going to take the derivative of this right here and then multiply by -1 at the very end. So I have a quotient rule. It's denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. And that's 2 times x squared minus 1 times 2x. When I take the derivative of this, it's a u to the n form. Its derivative is 2 u, x squared minus 1, n minus 1 to the first power, times the derivative of x squared minus 1, which is the 2x.
Right?
Yep, exactly right. All over,
The u of the first one only?
say that again.
You only take the u of the first one only?
When I took the derivative of the numerator, all I had to do was take the derivative of this, which was 2x. But when I have to take the derivative of this denominator, which is what I had to do here, it's a u to the n form.
Oh, it's because it's squared. That's
Yes,
right.
yeah,
Okay.
that's right.
That's the only reason I did it.
That makes a difference, yep, that's it. And I get x squared minus 1 to the fourth power. And like I said, we got a negative to take out front. Okay, so put the negative back in there. So here's what I got right now, negative here. I've got x squared minus 1 squared times 2x. I'm going to leave that alone right now. Minus. Now, what I have here is a 4x times x squared plus 1 times x squared minus 1. Okay? I'm not going to give you one this nasty on the test, but I know it. X squared minus 1 to the fourth.
Hey, why is it to the fourth?
Because you have to square the denominator. That's the quotient rule. Okay, I still got this negative hanging out here, but look at, what do we have? I have an x squared minus 1 that I can cancel out. So one of those goes away. This one goes away. And I have this. One of those goes away.
And that's it?
No,
Then we gotta figure out
we got to multiply it out.
it curves up or curves down.
Yeah, we're going to multiply this out. That's 2x cubed minus 4x cubed. Okay? I have 2x cubed minus 4x cubed. Let me just multiply it out.
Minus 2x, no?
Yeah, minus a 2x and then minus a 4x. But let me multiply it out. So I've got 2x cubed minus 2x minus 4x cubed minus 4x all over x squared minus 1 cubed.
Which equals minus 6x.
Yes, that's true. So here's what I have. I have a negative 2x cubed minus 6x all over x squared minus 1 cubed, and it's still a minus sign there.
It's not too bad.
It's not that bad.
So now you can flip it again and it'll become a positive.
Yes, I can take a negative 1 out of here, and that cancels this. So I'm going to end up with 2x cubed plus 6x.
The only reason you can do this is because of the negative divided by a positive. Because what about the bottom, x squared minus 1?
You can't do anything with that guy. We're going to leave that right alone.
It doesn't end up being still negative, the bottom?
No, it just stays the same. All we've done here is taken out a negative 1 from here, canceled this negative 1 to make it positive, and I've got one more step to take a 2x out front to give me x squared plus 3, x squared minus 1 cubed. All right, I'm going to stop there.
That's the second derivative.
That's the second derivative. Now, here's what I want to know. Where is the second derivative? Positive, negative, and 0. Well, let's answer the question of positive first. Where is this second derivative positive? Let's take a look at this.
Draw that or
No, I'm not going to even draw it. What I'm going to do is do this. Watch this.
Nowhere.
equal to 0?
Well, equal to 0 is really simple. That's x equals 0. When x is 0, the second derivative is 0. This is our point of inflection right here. That's the only place it's equal to 0.
No, but if you put plus it equal to 0, you would know where it goes from positive and where it goes to negative. Because anything under 0 would be negative at that place, under x. You see what I'm saying?
No. Here's an well,
Say -1.
In other words, I said if it's equal to 0, you find x, and you know where that x pretty much changes from negative.
yeah,
to
that's true,
positive.
but I've got, no, that's true, I see your point. But you got to take into account the denominator as well, though. You know, the numerator, yeah, when x is less than 0, this is going to be negative, this will be positive, but you got a problem here. X squared minus 1 is going to be negative when x is from 0 to -1, but then it's positive when x is less than -1. So you're going to have to break it up according to the denominator. But, all right, here's what we're going to do. We're going to do what Nick says.
No, it's okay. Just do it the way you.
Well, it amounts to the same thing. Watch this. When x is less than -1, let's break it up just like I have it here then. Okay, when x is less than -1, this is going to be negative. This is going to be positive. When it's less than -1 and I square it, it's going to be greater than 1, and this will be positive. Okay? So, what do I have here? When x is less than -1, I've got negative, positive, positive.
But it can't
It'll be a negative. Say that again now?
It can't be a -1.
No, it can't be -1, but when it's less than -1, the second derivative is negative, because that's negative, positive, and that's negative. And it is concave down, and that's what we have. Let's take a look at the x's between -1 and 0. Between -1 and 0. Between -1 and 0, x is negative, x squared plus 3 is positive, x squared minus 1 is going to be negative, because when you square a number between 0 and -1, you're going to get a number less than 1. Subtract 1, this will be negative, cubed is negative. So what happens? Negative, positive, negative. What do we get when we have negative, positive, negative? It's going to be positive. So for these values, it's positive, and check it out, concave up. Let's
Anything bigger than less than 0.
say that again?
It's anything between 0 and -1, right?
0 and -1, correct. Anything between 0 and -1, this quantity here is going to be positive, and we got a graph that's concave up, which is what we have. Let's take the x's from 0 to 1. 0 to 1. Positive, positive, negative, cubed, negative. From 0 to 1, we get a second derivative that is negative. Positive, positive, negative is negative. Okay? And we got concave down. And when x is greater than 1, what do we have? Positive, 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 positive. Concave up. Now, here's what I'm telling you. I'm not going to give you one like this in the test. I mean, it's not going to be this complicated. If you do get one this complicated on homework or something like that, the first derivative is telling you, by looking at it, where it's concave up and down. That first derivative is forced. You should be able to look at this and say, okay, concave down, second derivative, negative here, positive here, negative here, positive here, done, end of story. Okay, I'm just pointing that out. Okay? All right, that's the first one. How are we doing? Guys okay? All right, I think you guys should do the next one. Okay. I think you should do the graph. Here's what I think you should do. Graph rising, where the graph is falling, where we have horizontal tangents, where it's concave up, where it's concave down, and where we have points of inflection. Maybe points of inflection. And you should sketch the graph. Okay? Notice I didn't ask for asymptotes. Why? Because polynomials don't have asymptotes. Okay? Go ahead.
I just have one question.
Yeah, go ahead.
When you're taking the derivatives of that first number, is that 3, will that 3 will stay there? Oh, wait, hold on, never mind,
Okay.
got it.
Okay. Glad I could be of help. It's the guy. Whoa, look at that. The old video camera is in our way. Three.
Parts uploaded.
Really?
Mm-hmm.
To your YouTube account?
No, to our
Mine?
YouTube. I made one up. So calculus.stcc.
No kidding.
Yeah, I'll give you the password.
Wow, pretty cool.
Yeah, it's for next semester and the semester.
Wow.
Hopefully, maybe we'll get another room with a better.
Well, this one isn't bad. I like this one.
Yeah, well, you'll see when you watch the videos.
Oh, so
The
you're
voice
saying
is fine, but what is it called?
the video? The video is not good?
The video itself, like you're moving your arm around, and there's like pixels, kind of like it.
Wow.
But that's all right. Like,
I should get a new arm then, huh?
no, it's not your.
Oh, it's not my arm.
Okay. Is it one of the constants on the bottom that can be brought up?
You want to bring it out front. That 1/3 that's in front there, just take it out front. It's a constant. And then you want to take the derivative of x cubed and then multiply by the 1/3. You don't want to use a quotient rule on that.
No, that's what I was asking.
I'm worried about Vitali.
I'm not.
You're not? Something.
He's got a pretty good grasp on things.
Vitali's, yeah, he's good. He's good. Kind of worried about Danny, too.
What's the other dude? He's been gone for like 2 weeks.
What's that?
Does anybody send me emails when they don't come in?
Sometimes people do.
He's in my, he's actually on my 3D modeling team for engineering 203.
Has he been there?
Yeah, he works a lot. He works for the school.
Oh, really?
I don't know.
Wow.
What
I don't
heck's he?
know, man.
I'll tell you one thing about Calc 1, though. Many people in the Calc 1 are taking it for a second time. And oftentimes, they understand it totally, and they can miss quite a few classes and still do well.
Yeah,
That's often the
I just
case.
don't ever want to take a class twice.
Yeah, I don't blame you.
So do you put it to 0 or? That's the derivative.
That's the derivative, that is correct. And you do want to set it equal to 0. You want to find out where it's positive, where it's negative, and where it's equal to 0.
Where it's equal to 0 would be this. 2.
And negative 2. You got to get 2 roots there. When you take the square root, make sure you get plus or minus.
Ah, that's right. Okay, so it's that, and that's that. Correct?
Yeah, that is it. That's the first derivative right there,
And
man.
then,
Good job.
if I didn't know this graph though, like if it was a cube, how would I?
Then you'd have a problem. That's why I'm going to give you a cubic, so the first derivative is quadratic, and you will be able to do the graph.
No, but I want to know how to do it.
You would do the cubic. How would you do the cubic? You're doing a cubic right now. You would do what you're doing right now.
No, it's not a cubic. Let's say if it was a
Fourth degree.
quadratic, or like 4. I don't know how you would call
Yeah,
it.
it's a fourth degree,
Yeah, 4th degree.
and the first derivative is cubic.
Cubic, yes.
Yes, third degree. And I'm telling you, what you're doing right now is graphing a cubic equation. That's the one I gave you. You would do to that first derivative what you're doing right now to our function.
Oh, so you can do it twice?
Yes, you would take its derivative and second derivative and find out how to graph it from there.
So you would find out if you find a graph to graph a graph.
Yeah, that's basically right. You won't be asked to do that, though. You won't be asked to do that kind of a thing.
And negative means it's falling, correct?
Yes. Oh, Trent, it just dawned on me where she was.
Oh, yeah?
Yeah,
Where is she?
Mount Holyoke.
Oh,
With my daughter, there's a guest lecturer giving a lecture on climate change. And so she went there to Mount Holyoke.
Who?
My wife.
On climate change?
Yeah. Yeah. Mount Holyoke every week brings in these high-powered speakers, Peace Prize winners, and it's just unbelievable. My daughter goes there now, and just likes going to all these lectures, and my wife often or sometimes goes as well. I would go, except there always seem to be on Thursday night.
Sorry. So then you just plug in 2, right? 2 cubed.
I got my derivative and second derivative, and I just know.
Now you want to know where the first derivative is positive, negative, and 0. And the best way to do that is to graph that first derivative, which is a second degree quadratic equation. You should be able to graph that quadratic. It's a parabola, yes. You should be able to graph it.
move down.
Over 3.
What's that? It opens, that first derivative, that parabola is opening up.
What is 8/3? 2 1/2. 2 1/3, right?
2 2/3.
No, 2 2/3. Okay. 2.
You with me on that?
Yeah.
I got,
Here's where it goes. I'm not sure if it goes up after that or not. Wait, if it's falling, that means.
oh.
You got it?
It's just a parabola, I mean, not.
Yeah, it's not, yeah. And then the second derivative